Hello, everybody. So, what we're doing here is kind of section 4.5. We're kind of going in random order, mildly, but we're still on the same topic of um, solving quadratics. So this is just another strategy to solve quadratics. What we've been doing the past few days is solve quadratics that look like this. We kind of have usually all three of these things, and um, especially mainly most of the problems we've seen have had that guy in the middle. Today we're going to be seeing a lot of problems where that's not there. So we're going to be seeing a lot of problems without the number in the middle, and there's an easier way to solve this than factoring, because I understand, I get it, factoring can be kind of confusing sometimes, so we're trying to avoid that if we can, just find a bunch of different strategies that can use, just like a toolbox. If you got a bolt, there's lots of different ways. Oh man, I'm just bad at drawing a bolt. If you got a bolt, there's a lot of different ways to take it off. You can use a socket wrench, a screwdriver, or it's not a screwdriver. I don't know what I'm talking about. But if you could use a socket wrench, a regular wrench. You can use the pliers. Depending on what you need to do to get the bolt out. There's lots of different things you can do. So I'll slow down my talking here, but yeah, just again, just throwing out a bunch of different tools on how to solve them. So square roots, look like this. Here's an example. Square root of 4. Well, the main difference that we're going to say today is that usually we've always said square root of 4 equals 2. The problem is that doesn't cover all the bases. Actually, it equals plus or minus 2. Because negative 2 squared gives you a positive 4. And 2 squared gives you a positive 4. So we're going to have two answers. And the two answer thing makes sense with quadratics, because a lot of the problems that we saw, yesterday when we were factoring and stuff, definitely had the two problem thing. And remember that two problem thing comes from drawing that U and having those roots, those zeros, whatever you want to call them, where your parabola crosses the x-axis. So, this all kind of makes sense, hopefully, in the grand scheme of things. So this is just another way of solving them, and the main thing to remember is this plus or minus. That's the numero uno thing we want to remember about the quadratics. So first of all, we're just going to learn some properties about square roots. I don't know, I don't think any of these are a surprise by any means, but so the first one is the product property. That means we can split up quadratic or square roots that are together. We can split them up into two things. So here's an example. The square root of 18 is the same as the square root of 9 times the square root of 2. And so this property allows us to split them up. What that allows us to do is that we can simplify the square root of 9 to 3 square roots of 2. And that looks nicer. To a mathematician, this makes us very happy. That does not. If I had a sad face pen, I would use that. But we want to simplify them as much as we can. Get that thing under the root as small of a number as possible. And it works for quotients too. I'll do an example in a different color here. An example for quotients would be something like square root of 9 over 64. Oops. The quotient allows us to split this up, so we can do square root of 9 and square root of 64, and we can simplify those into 3/8. So again, being able to split up that quotient is really nice, because then we can get really easy, nice little numbers over there. So very advantageous to us. So we can simplify some of these. Again, I hope this is kind of review for you from Algebra 2. 80. We want to break, for any of these, we want to break them into perfect squares. Perfect squares are numbers like this. They're numbers that are really nice to take the square root of. So just want to keep those in mind. So 80, we can break that up into 16 times 5. The square root of 16 is 4. and the 5 is still underneath our square root house. We can pull the 16 out and we can transform it into a 5 because this is really like 2 4s. And when you have 2 of something under a root, that's really 1 outside it. So if that's confusing you, just make sure you concentrate on the square root of 16 part. But here's another one. I'll do green. So we multiply those. So that'll give us 126. We can break 126 up into 9 times 14, I believe. And then the square root of 9 is 3. Again, to a mathematician, which all of us are aspiring to be, I know. But, whatever. To mathematicians, this looks a lot nicer. Just like people don't wear striped shirts with, if you have a striped shirt, you don't usually wear that with like a polka dot pants. It's kind of funny. Or you look like a referee or something, I don't know. Anyway, I'm just saying, people think math rules are weird, but fashion rules are just as weird sometimes, so whatever. It's all about perspective. This one is the quotient rule, so we can break this up into the square root of 4 and the square root of 81. We know the square root of 4 is 2 over 9. That is a great example of a really nice simplification of roots. So this one again, same idea, quotient rule. And then we can simplify the bottom. So it's nice. Okay, moving on. Spent too much time on that. Next thing, solving quadratic equations. So this is really easy. You just got to get the get the squared by itself. So we subtract 5. Get 36, divide by 3, and we get 12. Now, when we do the square root, we got to think back to what I said at the beginning. We got to do that plus or minus thing. So our real answer looks like this. But I know 12 is like the square root of 4 times the square root of 3. So our final simplified answer is that. I went through that really fast, but again, you want to get the x squared by itself first. And that's what I did up to here, and then you can simplify the root to get that. Next one, again, I want to get this squared by itself first, so I got to get rid of 1/5 by multiplying by 5. The opposite of a fraction is multiplying, And then I got to get rid of the squared. But when I do that, got to do the plus or minus, and then we subtract 3. And usually we put the -3 in front of the plus or minus so it doesn't get confusing behind the root sign, because sometimes roots don't end very well, or people aren't very good about ending the roots correctly. So we want to look for an answer that looks like this. I believe it's that one, letter C. So our again, strategy here, get the squared alone first, then do the square root, and we got to make sure we do our plus or minus, and then we write the number. The plain number has to just go in front, because the root is like a prison. It's 35. We can't mess with it. We can't mess with that prison until the root is gone. So there you go. And then our last one, very similar to the one we just did. It's going to give us an ugly fraction. Fantastic. Glad I picked this one. So we got to get the squared by itself first. Do the square root. And then make sure we do plus or minus. I almost forgot there. Oopsies. That would have been embarrassing. And then we add the 2 over. And that is our answer. That's not very pretty looking. We'll talk about on Thursday how we can make this look better. It's kind of ugly. Just like roots with fractions for mathematicians, just not a very pretty situation. But again, we'll talk about on the next day. The next lesson will be about how do we make roots look better. Give them a little makeover so they don't look so messed up. Classy, not trashy. Anyway, so there you have it. Solving with square roots. Get the squared alone first. So divide by 3 here. Then do the square root. When you do the square root, make sure you put a plus or minus, and then you just put the normal number in front. So that's it. We'll see you on the next lesson.